We all know about Albert Einstein, right? Old guy with the big brain. So according to Albert Einstein's special theory of relativity, no object can move faster than the 299,792 kilometers per second of speed of light in a vacuum. It seems improbable that mankind will ever be able to launch spacecraft beyond the Milky Way due to this speed restriction. There may be a way past this cap, according to a recent study by Eric Lentz of the University of Göttingen. The problem is that his plan needs a lot of energy, which means it might not be able to launch a spaceship. Stay till the end to find out how a warp could be made utilizing only regular matter and not exotic matter. Welcome to our channel, where we provide you with facts related to space and technology. Before heading on to the video, make sure to like this video, subscribe to the channel, and hit the bell icon so you may never miss any of our updates. When you turn on a light in a dark room, the light fills the space almost instantly, and you would not even notice that it is moving. This is because light moves so quickly. The light year, which represents the distance light can travel in a year, is another unit of measurement related to light. This amount equates to roughly 6 trillion miles, 10 trillion kilometers. It is one method by which astronomers and scientists gauge the vast distances present across the cosmos. As was previously said, the universe is so big that it can take years for light to travel between 2 points. For example, the moon is roughly 1 light second away if light travels from the moon to our eyes in 1 second. The sun is around 8 light minutes distant, but sunlight travels farther and takes longer to reach our eyes, taking about 8 minutes. It takes light from Alpha Centauri, the star system closest to our own, around 4.3 years to reach us, making it 4.3 light years away. From a few light years to a few billion light years out, there are other stars and objects beside our solar system. As a result, all that astronomers see in the far-off universe is past. When they examine distant objects, they observe the light that depicts those objects as if they were now the beam that left them. Even though light can be used for a variety of exciting purposes, researchers have looked for ways to move at the speed of light. The CEO of SpaceX, Elon Musk, wants to establish a colony on Mars, but his explorers must endure a minimum of 5 months of space travel before arriving there, depending on how close the 2 planets are to one another. This may potentially be almost a year, and that is before it lands on the red planet with all the dangers it carries. They can, however, travel at the speed of light and complete the long journey in under 4 minutes. To accomplish moving at a very fast speed, researchers have experimented with a wide variety of techniques. However, there has always been a problem that other solutions could not address until a scientist revealed a new finding. It is extremely difficult to even approach 1% of the speed of light, which is still quite quick considering you could go from Los Angeles to New York in just over a second. One word may describe the issue: energy. Anything motion has energy, which physicists refer to as kinetic energy. You need more kinetic energy to move more quickly. The issue is that increasing speed requires a lot of kinetic energy. 4 times as much energy is required to make anything move twice as fast. It takes 9 times as much energy to make something move 3 times as quickly, and so on. For instance, it would take 200 trillion joules to accelerate a 110-pound teenager to 1% the speed of light. That is approximately equal to the daily energy consumption of 2 million Americans. Consider the EM drive, which was hailed as the device that would quickly transport mankind to the farthest reaches of the universe. Theoretically, this invention, which has already received a patent, works by enclosing microwaves in a shaped chamber, where their bouncing generates a push. Since there is no fuel input and no thrust output, the closed chamber will appear to be moving by itself from the outside. EM drive is based on Newton's second law, which says that force is the rate at which momentum changes. An electromagnetic wave has a specific momentum that it can transfer to a reflector at the speed of light, producing a little force. The EM drive, which appears straightforward yet fundamentally flips our understanding of physics on its head, is made possible by this accumulated little force in a huge amount. We wonder how the waves begin to move, how they keep moving, and where their impetus comes from because there is no energy going in or coming out. Many scientists don't take EM drive seriously because you need an explicable push to have spontaneously created momentum. If EM drive is successful, a lot of what physicists believe to be true about the cosmos is disproven. Even physicists at the Dresden University of Technology put the EM drive to the test, demonstrating that the NASA and Chinese results indicating thrust were all false positives caused by other influences. But according to Dr. Eric Lentz, a physicist with more than 10 years of experience in real-world applications, the warp drive exhibits an enormous promise. Lentz wasn't even the first to work on developing the warp drive into a practical, non-fictional technology. Miguel Alcubierre, a mathematician from Mexico, made the first attempt. His suggestion was what launched the official warp drives literature in 1994. Unfortunately, the dreadful exotic matter is a co-ingredient of the Alcubierre warp drive, as it has come to be known, which demands an incredible amount of energy. Researchers haven't even seen this highly radioactive material in nature, much less developed it. It's all just theory. Since then, a few modifications have been proposed, including one by Dr. Harold G. Sonny White, a senior NASA engineer, in 2010 to the Alcubierre's drive's physical design. Even though his revision required far less exotic matter than the Alcubierre method, the amount of energy required was still too high. Hence, his solution was still impractical. A different team of Swiss researchers by the name of Applied Physics, or APL, presented their theory. Remarkably, their drive's warp bubble may be created without using any unique materials. Though exceeding the speed of light is the goal of space travel, their model was unable to do it. Lentz begins by referencing the physical construction of the traditional Alcubierre drive, on which practically all other solutions are based, to illustrate how his ideas differ from those that have already been put out. According to him, the Alcubierre solution gave a clear illustration of what a warp drive would do, which is to constrict space directly in front of the ship or transport's center section and to expand the space directly behind. This image depicts the warp drive as a curved wave that a ship will ride to its destination. Lentz contends that while being the foundation of warp travel, it is not even an important component. He claims that an answer put forth by scientist Jose Notario in 2002 demonstrated that expansion and contraction were not required to move the ship ahead. He had to reconsider how a warp could be made utilizing only regular matter and not exotic matter because of his efforts. Notario was able to demonstrate that the expansion might be insignificant. This is an important development because it eliminates the need for exotic matter. By adding to Notario's theory, Lentz developed his variant that, in his opinion, is more practical because it is based on traditional physics. Lentz stated that his method differs geometrically from Alcubierre and most others because of how the energy is distributed around the warp bubble. Aside from this significant material distinction, the energy is contained in a tiny torus between both of the areas of strong expansion and contraction in the Alcubierre solution, where the energy density and curvatures are separated from one another to the maximum extent possible. Instead, Lentz's model has closely associated curves and sources, with nearly perfect overlaps between the high energy density and high expansion and contraction zones. Lentz's idea is perhaps a more workable warp solution than others previously offered because of these geometrical differences between them. Lentz's warp drive is still only a theory, of course. However, he does see some immediate actions that may be taken to try bring his theory closer to reality, which, like all prior drive hypotheses, includes lowering the amount of energy required. He anticipates many more developments in the coming years and believes they are underway. Do tell us about your views in the comments section. If you have reached this far, like this video, subscribe to our channel and press the notification bell so you may not miss any future updates. See you in another video. Until then, take care.